Okay, so we wanted to do a little video about our types of matter. And so, first of all, keep in mind that matter is going to be considered anything that has mass and volume. So when we're thinking about, basically what isn't matter, we're talking about things like energy primarily, but really anything that's around you that you can touch, that you can feel, even things that you don't really realize, like the air and stuff like that, that is matter. And so matter can be really distinguished from one type to another based on the types of really the particles that are in them and how those particles are distributed within a container. So we can have really two types of things. We can talk about pure substances. Sometimes these are just called substances, and we can have mixtures. And so let's talk first about pure substances. Those are really our most basic. But keep in mind that mixtures are really made up of these pure substances, and our mixtures can be physically separated into the pure substances. So again, I could filter them to separate them, the mixtures, and I could pick them apart, things like that. And we'll get into that a little bit more later. So pure substances are one of two types. They are elements or compounds, and they can always be described by just one chemical formula. So elements, first of all, we've talked about them a little bit before, are our simplest form of matter, and they're going to be made up of just one type of atom. It still could be that we have two of the same atom together. That's, for example, what happens in oxygen. The oxygen that we breathe is actually two oxygen atoms bonded together, but it's just one type of atom. Some other examples would be things like iron or sulfur or carbon. Really, any of those things that you see on our periodic table, those are examples of elements. The other thing then that we can have as a pure substance is a compound. And so a compound is two or more different types of atom chemically bonded in a fixed ratio. So for example, water, H2O. I can describe water as being two hydrogens bonded to one oxygen atom. And it can be described with that formula H2O. And so we can describe a compound with just one chemical formula. Every particle that I find in either an element or in a compound is going to actually be the same. Okay, and so in a compound, it's just that we have these atoms that are chemically combined together, but those combined together make a compound, okay, make the one particle. An element, the particle type is atoms. And so if we were thinking about breaking compounds down, I can only break compounds down using a chemical reaction, okay? So some sort of chemical means has to be used to separate the parts of a compound back into elements. Okay, so let's compare this to mixtures. So mixtures, we also can actually have multiple types. So mixtures can be either homogeneous mixtures or heterogeneous mixtures. And so you might think a little bit about like the terms homozygous and heterozygous that you learned in biology. So homozygous, that, part being the same, that beginning kind of not prefix, but that starter there of our word, and hetero being different. Okay, and so homogeneous mixtures are going to be things that are the same throughout, okay, or uniform in their distribution of those particles. Remember, there's always going to be at least two types of particle there, but they're going to be uniform in how they are mixed together. Examples of this would be solutions. So solutions are again, mixtures where they look the same and consistent throughout. Tap water, air, those are examples of solutions. We can even have solid solutions, so to speak, and that would be things like metal alloys, bronze, and things like that. On the flip side then would be heterogeneous mixtures. And heterogeneous mixtures are non-uniform throughout, meaning that they're, when I take a sample from one corner and compare it to another corner, they may not really seem like they're made up of the same ratio of stuff. An example of a heterogeneous mixture would be a suspension. And so suspensions are things that typically say shake well. If you let them sit over time, particles will settle down to the bottom. And they have really much bigger particles. And so, for example, Pepto-Bismol would be a good example. And again, really anything that says shake well, so that you will mix those particles up. Okay, so heterogeneous, again, are particles that are going to settle out over time in a mixture, and homogeneous would be where they stay mixed together evenly, even over time. Now, we do get one more type of thing in between, and that is what we call a colloid. And so, in between our heterogeneous and homogeneous mixtures are colloids. And colloids are things like fog or jello or milk. And they really have this kind of in between particle size. And so, overall, when we're talking about these types of mixtures, we classify them into the different type, either a solution, a colloid, or a suspension, based on the size of the particles. And so colloids have kind of medium sized particles so that they, they're something where they're not big enough that they're going to settle down to the bottom, that gravity is going to make them settle to the bottom, but they're big enough that we can usually kind of see it. So they tend to be, make things kind of look cloudy when we look at them. So just to show you a couple of other examples then, and to think about this idea of the difference between solutions, colloids, and suspensions, usually what we do is we can do a test with light to determine which type of substance we have. That's an easier thing than trying to actually pull out an individual particle and measure the size of it. And so solutions will be something that are going to be clear. I can clearly see through them, and light will shine right through them, but I won't be able to see the beam of light at all. Colloids, on the other hand, will, maybe be a little bit cloudy. Light will certainly go through them, but they'll maybe have a little bit of a cloudy look, but not always. And so, when we actually shine a beam of light through a colloid, we will see the actual beam going through it. Suspensions will also do this. This is actually called the Tyndall effect, and that when we can see the beam of light like that. And so the suspension, the particles there are big enough also to basically scatter the light and allow us to see the beam. But suspensions would have particles so big that over time they would settle out to the bottom. So let me show you a couple of real life examples of this. So this example is showing us sunbeams kind of through, whether it's, I'm not sure if this is kind of smoky, a smoky area, or if it's a kind of foggy type of area. But the sunbeams that we can see there show us that we have this kind of colloid in the air where we have something that's suspended there. And so smoke and fog are really good examples of this. Here's another picture, and you can see again, we have right here a solution. So we have no scattering of the light. We can't actually see the beam. Whereas in our other one, it's a little bit cloudy. I mean, light will travel through it, but it's a little bit cloudy, and we can see the actual beam going through our mixture there. The last thing then is a suspension, and here's one that you can see. You can see that we have all this sediment that has settled down to the bottom. We could certainly mix it up and let it settle again over time, but we get this separation because those particles are now big enough that gravity is actually working on them. So those are our different types of matter. Again. Back here. Again, we have pure substances, which include elements and compounds that can be described by one chemical formula. And then we have mixtures, both homogeneous and heterogeneous, and those cannot be described by one chemical formula. But we can categorize them based on those different characteristics of how the particles are distributed.